please welcome on stage Kevin from Moonbeam, where he holds the role of a developer relations engineer. Round of applause, please. Kevin, stage is yours.
Thank you so much, Max. Can everyone hear me OK? Awesome, awesome. Well, thank you so much to Maureen, and thank you so much for everybody who's made this conference possible. It's one of the best I've ever been to, so very, very appreciative to be here. And thank you, Maureen, for the invite. So today I want to talk to you about connected contracts. And I'm very excited to share with you this architecture for a new type of smart contract. And I want to start with a quick introduction to a couple different topics. So the first one is Polkadot. And you may already be familiar with Polkadot. Polkadot is a layer 0. It's a blockchain of blockchains. So you're not going to deploy your smart contract directly to Polkadot itself. Instead, you would deploy on a layer 1 like Moonbeam, which is running on top of Polkadot. So you probably know Gavin Wood, who is one of the co-founders of Ethereum. He, back in 2016, with two other co-founders, started with a vision for Polkadot. Now, it's a common belief, that the future is multi-chain. But back in 2016, it was very controversial to say something like, the future is going to be multi-chain. So they had this vision early on, and that has allowed Polkadot to have many years of development based on this multi-chain vision. And so what they thought was, how can we build the architecture of Polkadot to enable this multi-chain future? And what they came up with was the relay chain. And the relay chain is the layer 0, which connects the blockchains that are running on top of it. And then the parachains that run on top of the layer 0 are the layer 1 blockchains that provide specific functionality. So it could be privacy, could be decentralized storage, could be decentralized identity, or it could be connected contracts in the case of Moonbeam. But these specialized chains are not islands. They're meant to be connected. They're meant to talk to one another. That's enabled by XCM. And we'll talk more about XCM in just a second. So for a quick introduction to Moonbeam, Moonbeam is an Ethereum-compatible parachain on Polkadot. It's built with Substrate, which means that its underlying architecture is different from that of Ethereum's, but its developer experience and its end-user experience are quite familiar. More than just an EVM, we provide a huge stack, including a fully compatible Web3 RPC. So you don't have to change the type of request that you'd make. You can send the exact same request to a Moonbeam node that you would send to an Ethereum node, such as ETH get balance or ETH get logs, without changing any of the units or changing anything at all. Another thing, Polkadot provides a huge amount of functionality and features that you can inherit from as a parachain. This includes things like on-chain governance, forkless upgrades, and much more. However, Polkadot has a different type of account structure. It's a completely different private key. It's a completely different length of public key. And in order to access both these features of Polkadot, as well as the EVM, you'd have to maintain two different types of accounts. And so we made the engineering decision early on that this was not the ideal user experience. And so instead, we built a unified account structure. So you can use a single Ethereum account, a single Ethereum private key, the same one that you have in MetaMask right now without any changes. And you can interact with both Polkadot and Ethereum functionality. And we also have a huge number of developer tools and integrations. So everything that you're familiar to working with, that could be Hardhat, that could be Truffle, Remix, or Scaffold ETH. It all works without any compromises. And they're not forks either. Because of our commitment to maintaining Ethereum compatibility, none of these integrations require extensive changes or configuration. They all work straight out of the box. So before I go any further, I just wanted to mention that Polkadot is a layer 0. Kusama is also a layer 0. And Kusama is a more experimental network. It's not a test net. It has real economic value. But it's a place where exploration and experimentation is encouraged. And so there's a huge community of early adopters on the Kusama network. And so we've adopted a similar brother-sister strategy for Moonbeam and Moonriver, where Moonriver is the more experimental mainnet. So let's talk a little bit about interoperability in Polkadot and how XCM enables that. XCM stands for cross-consensus messaging, and it's just a language for blockchains to communicate. Just as humans use a language to talk to one another and to be understood, XCM is the same for blockchains. So when you send an XCM message, you specify a specific set of instructions. These instructions include a couple different steps. So if you wanted to transfer funds from one chain to another, you would include a series of perhaps 5 or 6 steps. And some of the steps include paying the relevant transaction fees, refunding any excess fees, and things like that. These instructions are executed in an XCM virtual machine, which is a limited purpose virtual machine. And it's also very lightweight and efficient. So for XCM, these instructions, they have to be able to be executed in an on-chain manner. And so they have to be resource efficient. And the other thing that's really neat about XCM is that it's forwards and backwards compatible. So there are dozens and dozens of different parachains that are on Polkadot and Kusama. And if Polkadot upgraded a version of XCM and said to all the parachain teams, you need to upgrade at the same time on Sunday at 2 a.m., you can't coordinate all these teams to upgrade at a specific time. Instead, the teams can upgrade at their convenience. And so the very first part of every XCM message, the very first line, is a version tag. So v0, v1, v2. And that tells the destination chain how to interpret the rest of the message. And so this means if there's a new feature or something like that, the chain would still have to upgrade. However, what this means is that it's never going to introduce a breaking change. The chain will always be able to interpret the message correctly, regardless of which version of XCM it's running. But before you can send an XCM message, you do have to have a channel set up. And a channel is a pipeline for communication between 2 parachains or between a relay chain and a parachain. And these channels, they're one-way means of communication. So if you want to have back and forth communication, you do need to have 2 channels. And these are opt-in. So the origin chain will send a request to the destination chain asking for this channel to be opened. And then the destination chain will need to accept that. And when I say accept that, I mean the token holders will need to, via a vote, accept the opening of this channel. And you can see here that vertical message passing refers to communication between the parachains, such as Moonbeam, and a relay chain. And that's vertical message passing. And then cross-chain message passing refers to parachain-to-parachain communication. You can see right now, all those messages are routed through the relay chain. But in the future, Polkadot will introduce direct parachain-to-parachain communication so that there isn't this extra strain on the relay chain. There is a map here where you can see all the live XCM channels. And these are changing on a weekly or perhaps even daily basis. Kusama has been around for longer, and Moonriver was launched in August of 2021. Polkadot itself has had parachains live since about January of this year. So that's why the Polkadot section has fewer channels set up, but it will be growing. Let's talk about connected contracts. And first, I want to recap. So we mentioned that the future is multi-chain, but why is the future multi-chain? For one, chains are becoming increasingly specialized. So you might have a game or a DEX. You might have any type of application that becomes large enough that it might require its own chain. Or you might have a layer 2, which is deployed to a brand new layer 1, perhaps. So there are increasing numbers of chains out there. There's also an increasing number of users coming into the space. With that comes a demand for block space. Another idea is that frameworks like Substrate make it easier for you to launch a new chain. They take away a lot of the complexity you don't even need to provide your own security, especially within Polkadot. You can rely on the relay chain to provide the proof-of-stake security for your application. And so with this, we know that as time marches on, there are going to be more and more blockchains. So if you were to ask a team, yesterday or last month or at any time, if you were to ask them, what's your multi-chain strategy, right? The one of the past has kind of been this centralized deployment model, which is you pick a chain, you deploy to it, you announce to your users, here we are, come find us. And users would have to get the native token of that chain, perhaps through an exchange. Perhaps they would use a bridge, maybe get a faucet drip while using a bridge. And this is great for developers. You have one place, you have one chain and deployment to maintain. But pretty soon you want to grow, you want to expand, and you want to gain access to new users. And so you might say, we're going to move to a multi-instance deployment. And a multi-instance deployment is exemplified well by SushiSwap. SushiSwap has deployments across many different chains. And it's great to allow them to access users on all these chains. But one problem might pop up, and that's that they're fragmenting liquidity across these different chains. And what's more, the developers have to maintain 16 or 15 or 20, whatever the number is, different deployments across chains. That's a very, very difficult task for any team. And although you can access these different chains from the same homepage, SushiSwap's website, you can access them from the same front end. These chains, they know nothing about each other. They don't mutually benefit each other in some way. And so there is a third option. And the third option is a connected contracts approach. And so with Moonbeam, via XCM, we mentioned that you can access other parachains or other layer 1 blockchains within the Polkadot ecosystem. That includes not just bridging around tokens from chain to chain, but that includes accessing functionality on other chains. So that could be remote execution. That could be making a contract call to another chain. It could be using an identity that's stored on another parachain. XCM enables this type of interoperability within Polkadot. However, we're not focused just on Polkadot. We want to allow our users to access functionality across many different chains. And that could be Ethereum, Cosmos, Avalanche. These are just a couple of examples, but there are many, many more. And so the idea is that contracts that are on Moonbeam as a home base can access features that are deployed across many different chains. And so another mental model to think about this is that you're acting not just on local assets, but on assets that could be on other chains. You could be enacting swaps remotely to another chain as one example. So the key innovation that enables this is general message passing. And general message passing is available on Polkadot in the form of XCM. But there's also a couple different ways. It's not just within Polkadot. We're working with Axelar and Layer 0, and they're enabling connections between a number of different chains. So I like their definition, Axelar's definition, of being a universal overlay network. They're across many different blockchains, and new ones are being added on a very regular basis. And so by sending a message to another chain, you can do things like make a contract call. And it's not that difficult it's not that different from making a function call on a normal chain, the one that you're currently on. The only thing that's different is you're going to be specifying the chain that you want to call the contract on, and you're going to be specifying that contract address, and you're going to be supplying a payload of parameters that you'd like to provide to that contract. There might also be another parameter, such as a gas refund address or another optional parameter that you'd like to provide. I want to share with you an example of something that's already live and in production today. And this is Lido's liquid dot contracts. So you may already be familiar with staked Ethereum. And Lido was looking at the Polkadot ecosystem, and they wanted to provide this similar type of product, but for Polkadot. And Polkadot does not provide smart contract functionality on the layer 0 itself. So that's where Moonbeam comes in. And so what Moonbeam enabled Lido to do is to have a series of smart contracts on Moonbeam. Users can deposit DOT on Moonbeam, and then Lido can, via XCM, move that to the Polkadot relay chain, and then stake that in a native way. There's no off-chain anything going on. All of this is happening on-chain in a trustless manner. And so keep in mind that Polkadot and Moonbeam are separate chains. So being able to call and make a transaction on another chain is a big deal. And it really embodies the future of connected contracts. Another example that I want to share with you is regarding Prime Protocol. And Prime Protocol is building a DeFi prime broker. So a prime broker you may already be familiar with, but in the traditional sense, a prime broker works with VIP clients at a bank. And typically, the VIP clients will have all different sorts of assets. They'll have stocks, bonds, maybe a house, maybe their cars or something with the bank. And they might come to the bank and say, I'd like to take a loan out against my collateral. And the bank will say, sure, you've got all these stocks and all these bonds. We'd be happy to give you a very reasonable rate because we have all these assets here. When you're borrowing from a lending protocol on a blockchain, typically you have a very limited subset of assets which you can provide as collateral. And your collateral also has to be co-located on the same chain on which you'd like to borrow. So typically, if you have a lending and borrowing protocol on Moonbeam, you would need to deposit your collateral into that lending and borrowing protocol. And as an example, let's say you have ETH. You have ETH on Ethereum. You'd first have to bridge it to Moonbeam, deposit it into the lending and borrowing protocol, and then you'd be allowed to borrow. But what Prime Protocol is working on is they have this hub and spoke model. So they have the hub, which is on Moonbeam. That's the brains of the smart contract. So that decides how much you can borrow. It decides all sorts of decisions, such as any sort of liquidation decisions that need to be made. But it also has satellite deployments on other chains. So you can deposit your ETH into a satellite contract on Ethereum, and Prime Protocol can recognize that deposit and then say, OK, great, I'll allow you to borrow this amount on Moonbeam. If there were any decisions that needed to be made, such as liquidation or anything like that, a message could be dispatched from Moonbeam to Ethereum in order to liquidate some collateral. Why is this such a big deal? Because without having to bridge, you can keep your funds on the native chain, and you can also use a variety of different assets as well. So you're not limited to one wrapped flavor of an asset. And it's a better user experience for the borrower and the lender. So overall, right, why are we so excited about this connected contracts approach? We're fundamentally interested in providing better user experiences. We want users to be able to access features across a variety of different chains. So this connected contracts approach is opening up features that might not be accessible to users before. It also solves fragmentation issues, where you can treat liquidity as more of a whole instead of segmented pieces across many different chains. And it also allows for efficiency. Imagine, instead of having to maintain deployments across 16 different chains, instead you can have a deployment on one chain where you can maintain and upgrade and iterate in one place. And another benefit is to hide the infrastructural complexity and make it a much more seamless user experience. So that's why we're so excited about connected contracts. And to encourage this, we have a hackathon called the Moonbeam Connected Contracts Hackathon. That's running until September 26th. And we'll be doing another hackathon, of course, before the end of the year. But you can access that website at moonbeam.devpost.com. So if anybody has any questions, I'd be more than happy to take them. And you can also access our link tree right here.
Well, apparently there are no questions.
Awesome.
You've
Thank
done
you so
a great
much.
job. Yes, thank you so much. Another round of applause. And